Why do we use Pepper when hashing passwords? Isn't Pepper useless because it's plain text in the database? Well, it turns out that it's not. Short answer, the reason why we use Pepper is because it adds another layer of complexity in the hacking process. For a hacker to do a dictionary attack, they need to know multiple things: the password hash, the salt, the pepper, and the way they are combined in your program. And this creates a more difficult challenge for hacking passwords using a dictionary attack. But if you want to learn more about hashing passwords and more details, watch some more of this video. Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios, and today I want to talk about hashing salt and pepper. First, when we first started to store passwords, we were storing them in plain text. This was a bad idea because too many people were able to see them. The developers were working on the application, the system administrators, the database administrators, a lot of people could see them. And also, if you had a SQL injection vulnerability, which was very common back then, people would have a potential attacker could extract the passwords in free text and just use them. So not a good idea. Then we realized, oh, we have this fancy thing called hashing. And hashing is a function that applies on a string, and it gets a string of a specific length as a result. And the interesting thing is, if you change a very small part, so let's say you only change one bit in the initial string, a lot of things will change in the resulting hash. And this means that you have very different values. So it's hard to guess. You cannot guess by approximation. You cannot say, if I have password AB but I'm trying AA, it will be very close to, the hash will be very close to AB. Now, how do you attack something like that? Well, you have a few options. The fastest option is rainbow tables. Rainbow tables means you get a huge list of words, ideally common passwords used by a lot of people, and you hash them with the algorithm of the day, and you end up with a long table. And if you manage as an attacker to extract, maybe using SQL injection, you extract a full table of usernames and password hashes, you can use the rainbow table. You take the hash, you search through the rainbow table, and it corresponds exactly to the password. So that's really cool because you just need to do a linear search, or if you are more fancy, it's indexed somehow in a database, so you can definitely find it very quickly. So we are talking maybe minutes or maybe half an hour, something like that, to break passwords. So the second option is, if rainbow tables don't work because the password is not one of the commonly used passwords, then the next way to attack it is by doing a brute force attack. And brute force attack means that you take strings one by one, try to make various combinations, and you keep hashing them, comparing with the hashes that you retrieved, and see if you can find the corresponding password. This is a very costly attack if you're doing it with passwords that are complex. For simpler passwords or very common passwords, again, not that complex. So usually hackers use a combination of these methods, rainbow tables, brute force, and what's called a dictionary attack. A dictionary attack means we start from a list of passwords and we hash them. We compare the hashes with the hash you have retrieved from the database. Now, obviously, the first thing we want to prevent attackers from doing is to use rainbow tables. How do we do that? Well, this is where we start to use salt. And salt is a string that you create. It can be a random string, it can be a string that you set per application instance, per server, per whatever. But it's a string that you have, and when the user is creating a password that is very common, let's say monkey123, this is one of the common passwords. Monkey123, instead of just hashing monkey123, you are hashing monkey123 plus my random salt, which can be a weird chain, weird string. We concatenate those and then we hash the resulting thing, store that in the database. How do you verify that the password is correct? Well, the user enters their password, you take the password, combine again with the salt, compute the hash, compare the hashes, and check whether it's the same password. Of course, this means that your application, if you want to change the salt, you need to reset all the passwords because you don't know the original passwords. So you need to ask your users to reset their passwords if you decide to change the salt. If an attacker manages to retrieve your user table with passwords, they get it, they try a rainbow attack, but because they don't know your salt, they have no idea, nothing in the rainbow table matches. Even if monkey123 is in the rainbow table, because it's not combined with the salt, you won't get the right password, you won't find anything. So this stops the fastest attack possible on hashes. Now, what can happen is, in that case, the attacker could try to retrieve the salt. Let's say they manage to retrieve the salt. Now what they can do is to do a dictionary attack, where they take common passwords, combine them with the salt, and compute the hash and compare the hashes with the ones they have. And they guess the password in this way. This is all good, but it's still too easy, right? Because if attackers can do that, maybe we can take this up a notch. Now there is a slight variation because they might also need to find out how you combine the salt with the password. The most common implementation is you concatenate the password with the salt, but it can be that you're using the salt first and then the password, or maybe you're doing some kind of weird combination between the characters, like the first three characters with before the first character in the word, and then second 5 characters, and so on. You could do something like that as well, a more complex algorithm that combines that. So what it means is that in order for an attacker to do a dictionary attack that is successful, what they need to know is the password hash, the salt, and the way you combine the password hash with the salt. And we'll assume that there are 2 options for the last thing, but still it's pretty good. I mean, it increases the time. But they can still do a dictionary attack. They could always do a brute force attack, but that is very costly, because in this case, if the salt is truly random and they don't find the salt, then they can do a brute force attack, but this means just going through all the possible combinations, and that's really, really expensive. Or they could, of course, try to guess the salt. They could say, monkey123, we have a list of common passwords. We are trying admin monkey123, 12356 456789, all kinds of common passwords. And then we are doing the brute force on the last part, but there's still a lot of combinations. All right, then could we increase their workload? Because security is a lot about making potential attackers work much more for you, then they need to work for anybody else. That's basically it. You need to increase the cost of hacking beyond the benefits. Well, we could add a second element to this, which is pepper. And pepper is again a random string, which is stored in plain text in the user table. And usually the way this works is you have salt and pepper. You still have the salt, which is unique per application or per instance. You have the pepper, which is specific for each user. And now you can get, when you compute the hash of the password, you get salt plus password plus pepper, compute the hash, store the hash. So now, how do you validate this? Well, you get the password from the user, you add the salt, you add the pepper, compute the hash, compare the hash with the hash they have, and you know whether the password is good or not. What do you do as an attacker? Well, as an attacker, in order to do a dictionary attack on this, you need to get the full user table. So you cannot get just the passwords, just the password hashes. You need to get the password hashes and you need to get the pepper for each password hash. You need to get the salt, which is stored somewhere differently, and you need to know how the salt, the password, and the pepper are combined for this specific instance. Each of these adds a new dimension. So if you don't know the salt, you need to do a brute force attack to figure out the salt, even if you know the pepper. If you don't know the pepper, well, let's say you know the salt, you need to do brute force attack on the pepper. If you know the salt and the pepper, you still need to know how these combine. So is salt plus password plus pepper, or is salt plus pepper plus password, and you have 6 different combinations. And remember, you don't know the password. So you're doing a dictionary attack, which means you're taking the most common passwords, but now you need to try them in various combinations with salt and pepper until you get something that is right. So that could be 6 different ways, if I'm computing correctly. But also, you as an application developer could make something even worse than that for an attacker, make their job harder by having some kind of dynamic algorithm that says, okay, this is, if the user's name starts with C, then we do salt plus pepper plus password. But if the user's name starts with G, then we do salt plus password plus pepper, and so on. And you have all these kinds of combinations that are hidden in your code. And this creates a whole other level of combinations for your potential hacker. So this is why, even if you have pepper that is in plain text in your database, it still shows, it still increases the effort for hacking your passwords. And that is why salt and pepper are so useful. Does this make any sense? Let us know in the comments. Ask any other questions you might have about this topic or other topics related to secure coding and cybersecurity as it relates to software developers. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.